On July 1st, 2025, a telescope in the mountains of Chile caught something moving across the sky that had no business being there. It wasn't orbiting the sun. It wasn't bound by it at all. Something was moving so fast, on a path so strange, that within days astronomers realized they weren't looking at anything native to our solar system. They named it 3I/Atlas, the third interstellar object ever confirmed passing through our cosmic neighborhood. And for months afterward, one of the most respected astrophysicists in the world looked at its numbers and asked a question most scientists wouldn't dare say out loud on camera. What if this isn't a comet at all? Most objects inside our solar system follow neat, closed orbits around the sun. Comets, asteroids, even the strangest icy wanderers we've cataloged over the decades, they all eventually come back around, tracing the same loop again and again for as long as we've been watching. 3I/Atlas didn't play by those rules. The moment astronomers calculated its trajectory, the math gave them chills. It was moving on a hyperbolic path, which meant it was never captured by the sun's gravity in the first place. It came from somewhere else entirely, some other star system, flung outward who knows how many millions or even billions of years ago, and it was simply passing through ours on its way back into the dark. It was traveling at roughly 250,000 kilometers per hour at its closest approach to the sun, the fastest speed ever recorded for a visitor to our solar system. At that velocity, this object had likely been drifting through interstellar space, alone. For a length of time, scientists still can't fully pin down, long enough that some estimates put its age at older than our own sun. Only 2 other objects like it have ever been confirmed by astronomers anywhere on Earth. This was just the third, and it immediately became the most closely watched of the 3. When it was first spotted, the object carried a temporary designation before the name 3I/Atlas stuck, and within days, observatories around the world had reoriented their schedules to prioritize tracking it. That kind of rapid, coordinated response is rare in astronomy, where most objects are cataloged quietly and studied at leisure over months or years. The urgency here came from a simple fact. Once an interstellar object like this passes through, there is no second chance to study it up close. It will never orbit back around for a follow-up observation the way a comet native to our solar system eventually would. Whatever data gets gathered during this one pass is likely all humanity will ever have on this particular visitor, which is part of why every observatory capable of pointing at it did exactly that. Here is where the story stopped being a simple watch the comet go by kind of headline. As Hubble, the James Webb Space Telescope, and a rotating cast of ground and space-based observatories turned their instruments toward 3I/Atlas, the data coming back didn't look like anything astronomers were fully used to. Its coma, the surrounding cloud of gas and dust that forms around an icy core as it warms near the sun, showed an unusually high ratio of carbon dioxide to water, a chemical signature that stood out compared to typical comets from within our own solar system. Its core appeared heavily irradiated, consistent with an object that had spent an enormous amount of time exposed to cosmic radiation far from any star's protective warmth. Later readings, gathered as the object rounded the sun and began heading back outward, picked up plumes of organic molecules and a water production rate that spiked by roughly 20 times normal levels. And it was accelerating in ways that pure gravity alone couldn't fully explain. A small but measurable, non-gravitational push, the kind of subtle nudge scientists usually attribute to jets of gas venting unevenly off a comet's surface as sunlight heats one side more than another. To be clear, comets do outgas. That part on its own isn't unusual at all. What raised eyebrows across the astronomical community was the combination of everything together. The chemistry, the trajectory, the sheer physical size of the thing. Estimates eventually placed its nucleus at somewhere around 2.6 kilometers across, making it significantly larger than either of the 2 interstellar visitors that had been confirmed before it. To most of the scientific community studying the data, this added up to a fascinating, deeply unusual, but ultimately natural object, an ancient icy wanderer from another star system behaving in ways we simply hadn't observed up close before. To one Harvard astrophysicist, it was something worth asking harder questions about before settling on the comfortable explanation. Avi Loeb has built much of his career on refusing to rule out the uncomfortable answer before the evidence is fully in. He is the same scientist who, years earlier, argued that a previous interstellar visitor named Oumuamua might have been artificial rather than natural, a claim that drew intense criticism from much of the astronomy community at the time, but also forced a public conversation about how confident we should really be when labeling something as ordinary. When 3I/Atlas showed up moving faster, larger, and chemically stranger than anything that came before it, Loeb didn't stay quiet. He published papers and public analyses laying out why he believed the object's trajectory and behavior were, at minimum, worth testing against the possibility that it wasn't a natural comet at all. He wasn't claiming certainty. He was refusing to dismiss the possibility before the data had fully come in, and he said so publicly, under his own name, with his own professional reputation attached to the claim. That is a serious position coming from a tenured professor at one of the most respected universities in the world, not an anonymous account online. And it is exactly why 3I Atlas became the center of a very real, very public argument between scientists who believed the object was simply an ancient, unusually active comet doing exactly what comets do, and a smaller but genuinely vocal minority willing to entertain the possibility that it might be something else. For several months in late 2025, nobody could say with total certainty who was right, because 3I Atlas was heading somewhere that would either deepen the mystery or help put it to rest. It was heading toward Mars. It's worth understanding why a claim like Loeb's carries weight, even when most of the field disagrees with it. Science advances partly by having credentialed people willing to stake their reputation on testing an unpopular hypothesis, rather than assuming the safest answer by default. Loeb has repeatedly argued that dismissing the artificial origin hypothesis too quickly, simply because it sounds far-fetched, is itself a kind of bias that good science shouldn't indulge in. His critics counter that extraordinary claims require extraordinary evidence, and that every anomaly observed in 3I Atlas so far has a plausible natural explanation. Once you account for how genuinely unusual an ancient interstellar comet's composition and behavior might look compared to anything native to our own solar system. Both sides of that argument were playing out in real published papers, not just social media threads, which is part of what made this particular object such an unusual case study in how science handles genuine uncertainty in full public view. On October 3rd, 2025, 3I Atlas passed within roughly 29 million kilometers of Mars, close enough that spacecraft already stationed at the planet, orbiters and rovers that humanity had spent decades placing around the red planet, got a rare front row seat to an interstellar object sweeping directly through the neighborhood. This was, for a brief window, one of the tensest moments of the entire event. Early trajectory estimates carried enough uncertainty that some corners of the internet ran with the idea that a Mars impact wasn't entirely off the table, and speculation about a potential collision spread quickly online. In hindsight, it was never actually that close in astronomical terms. 29 million kilometers is still a wide margin of safety. But the fact that an object moving that fast, arriving from that far away, could be tracked with enough precision to know exactly how it would thread past Mars without incident, that in itself was a remarkable achievement. The European Space Agency used data gathered from its own Mars-orbiting spacecraft, specifically its trace gas orbiter, to refine 3I Atlas's predicted path with roughly 10 times greater accuracy than ground-based telescopes alone could manage. It became a genuine test case for how humanity might track and respond to a potentially hazardous object arriving from deep space at some point in the future. In the end, 3I Atlas passed Mars without incident. No impact, no near miss in any meaningful sense. Just an ancient traveler, or whatever it truly was, continuing along its trajectory exactly as the mathematics predicted. The story did not end there. 3I Atlas reached its closest point to the Sun on October 30th, 2025, at a distance of about 1.4 astronomical units, placing it just inside the orbit of Mars itself. It survived that close solar passage without breaking apart, which is not something every comet manages when subjected to that much heat and radiation pressure. Then it swung back outward, made its closest approach to Earth in mid-December at a perfectly safe distance of roughly 270 million kilometers, and kept moving. By March of 2026, it was making its closest pass by Jupiter, still venting gas, still being tracked by observatories around the world, still handing scientists fresh data with every flyby it completed. Even a spacecraft already headed toward the Jovian system, the Jupiter Icy Moons Explorer, caught valuable observations of the object during its most active phase, adding yet another data set to the growing pile of evidence being gathered from multiple angles and multiple instruments simultaneously. As more evidence continued arriving, the mainstream scientific consensus solidified further. Every major space agency that studied the object closely, including NASA and the European Space Agency, reported finding no signature whatsoever of artificial technology. No engineered materials, no structured radio signal, no evidence of anything beyond natural cometary behavior, just an old, active, chemically unusual comet doing precisely what comets do, only faster, larger, and further from anything astronomers had directly observed before. Avi Loeb, to his credit, did not simply disappear from the conversation once that consensus began forming. He continued publishing detailed analyses questioning some of the object's more unusual behaviors, even after the natural explanation had become the dominant view among his peers. Pointing to specific anomalies, he argued still deserved a fuller explanation before the case could be considered fully closed. Most of his colleagues in the field disagreed with his broader conclusions, and said so openly in their own published responses. But the questions themselves became part of the larger story, a public reminder that even now, with humanity's most advanced telescopes trained directly on the sky, we can watch an object for the better part of a year, gather data from multiple spacecraft, and still find room for genuine disagreement about what exactly we are looking at. So what was 3I Atlas in the end? By nearly every measure the scientific community gathered across more than half a year of continuous observation, it was a comet. An unusually old one, faster and stranger than any interstellar visitor confirmed before it, carrying chemistry that originated in another star system entirely, shaped by billions of years drifting alone through the emptiness between stars before it ever crossed paths with our sun. But a comet nonetheless, by the overwhelming weight of the evidence collected. For a few months in 2025, though, one of the most credentialed scientists on Earth looked at the exact same data everyone else had access to, and asked out loud whether we were truly sure. And that question, however it was ultimately answered by the wider community, revealed something genuinely true about our current place in the galaxy. We now possess the tools to spot something arriving from outside our own solar system entirely, track its path precisely enough to know with confidence that it will miss Mars by tens of millions of kilometers, and study its chemical composition in near real time as it sweeps through our cosmic backyard and heads back out the way it came. It arrived from another star system, one we cannot identify and likely never will. It is already leaving ours behind, retreating back into the interstellar dark it emerged from, following a path that will carry it away from the sun forever, never to return to any part of the sky we can observe again in our lifetimes. The telescopes that tracked it, the spacecraft that happened to be perfectly positioned around Mars and Jupiter to catch it passing by, the scientists who spent months arguing over what its jets and its chemistry and its trajectory actually meant, all of that represents something worth pausing on. This is likely not the last object of its kind that will ever cross into our solar system. Astronomers already expect that improved survey telescopes coming online in the next several years will spot interstellar visitors, like this one, far more frequently than we have in the past, possibly catching several a year instead of one every few years. The real question raised by 3I Atlas was never really about whether this particular object was artificial. The evidence, gathered patiently over months by multiple independent teams using some of the most sensitive instruments ever built, points clearly toward a natural explanation. An ancient comet behaving in ways we simply had never observed up close before because we had never had the opportunity to study an interstellar object with this level of detail. The real question is, what happens the next time something like this shows up? Will our instruments be sensitive enough? Will our tracking be precise enough, fast enough, to rule out danger before speculation online gets ahead of the actual data? And will scientists on every side of a genuine disagreement, the ones certain it's natural and the ones like Loeb still asking uncomfortable questions, be given the room and the data access needed to work it out in public, the way this entire episode ultimately played out? Because somewhere out past the edge of what our telescopes can currently see, more of these ancient travelers are almost certainly already on their way in, carrying pieces of other star systems we will likely never visit any other way. And the only real advantage we have is the amount of warning we get before the next one arrives. There's a strange kind of comfort buried inside a story that started with this much uncertainty and ended with this much clarity. For a few months, headlines and social media threads speculated about an engineered object on a collision course with Mars, and for a while nobody could say with total confidence that they were wrong. That kind of uncertainty is uncomfortable, and it's exactly the kind of gap that speculation tends to rush in to fill. But the actual response from the scientific community wasn't panic. It was more telescopes, more spacecraft repositioned, more data shared openly between agencies that don't always cooperate this smoothly, and eventually, more certainty built the slow way, through observation rather than assumption. 3I. Atlas is gone now, or as good as gone, retreating back into the dark it came from, and it left behind something more valuable than a scare. It left behind a working demonstration of exactly how humanity should respond the next time something unannounced comes hurtling in from outside our solar system. Watch closely, argue honestly, and let the data decide.